Find all solutions, real or imaginary, using the method of your choice. 4 times the quantity x plus 2 squared plus 18 equals 0. Well, my choice would be to get x by itself and do so by first subtracting 18 to the other side. So 4 times x plus 2 quantity squared equals negative 18. Divide both sides by 4 so that we can get the x plus 2 quantity squared on its own. Then, let's see, this will reduce. If I divide 2 out of each of these, that would give me 9 halves. So negative 9 halves. In the next step, if I take the square root of both sides, then I have, to be careful, because I'm taking the square root of a squared variable, I need to make sure I consider the plus or minus case. Then that will leave me with x plus 2 on the left-hand side of the equation. And then a plus or minus. When I take the square root of a fraction, I can take the square root of the numerator and denominator separately. So, for instance, if I have the square root of negative 9 over 2, I could think of this as the square root of negative 9 over the square root of 2. The square root of negative 9, well, first off, we can enter the complex realm by factoring out the square root of negative 1 as I. Then the square root of 9 is 3, so times 3, and then put that over the square root of 2. So that would leave me with 3i over the square root of 2. And if I subtract 2 from both sides, I get x equals negative 2 plus or minus 3i over the square root of 2. And this is a perfectly fine answer, but it's generally considered poor form to leave a square root in the denominator. To get the square root out of this denominator, just multiply the top and bottom of this fraction by the square root of 2. And what that does is makes this instead negative 2 plus or minus 3 square root of 2. Actually, I'm going to put the I here, 3i square root of 2. And the reason for that is simply because when you put a number after a square root, it's hard to tell sometimes by handwriting if you mean for the value to be under the square root or outside of the square root. So if you put the values that are not under the square root in front, it makes it just a little easier to read. Then the square root of 2 times the square root of 2 would be the square root of 4, which is 2. And there, now we have the denominator rationalized, and there's a great final answer.